Hello! This video is going to talk about how do we take a data set, and if it looks to be linear, how do we draw what's called the best fit line, and then find the slope of that line. There are several pieces of computer software and apps for your phone, and then also apps or programs on the graphing calculators that can do what's called the best fit line. But if you don't have one of those, and you already have a graph made, it's pretty simple to find a best fit line using just a ruler. What you do is you use the ruler. Sometimes it depends upon how far your lines are or how far apart your dots are. You can lay the ruler on edge. You can just kind of line it up. But what we try to do is actually create a line where the line seems to go through most of the points. We may have a few points above the line. We may have a few points below the line. Let me try this one and see how it works. You might want to do this in pencil to begin with. So in case you don't have quite the right line, you can erase and try again. But I'm just going to take a chance that this one's going to be pretty good and use pen. And that doesn't look too bad. We have a couple of points here that are kind of above the line. That one's just above the line. This one's just below. That's just below. That's just below. That's just above. So we have a few kind of above, a few kind of below the line. I definitely, would probably not draw a line something like this. That's all of them are going to be above. I would probably not draw one like this because now I've got almost all of these endpoints that are above the line. I want to make a line that tends to go through most of the points, kind of through the middle of them all, but it needs to be a perfectly straight line. We are not going to be connecting dots when we do these lines. We just want a straight edge and make one complete straight line. So before I go any further, I should refer back to these. What I am doing is I'm doing the bottom set of this page of instructions. It's called Finding the Slope of a Line. And I've already done step one. It's called creating the best fit line. Now what I need to do is find 2 points that are on this line. And if I look at my original data points, 1, 2, 3, 4, 5, 6, 7, 8, I really notice none of them are on the line. But that is okay, because to do the slope, I really only need 2 points that are actually on the line somewhere. It's also nice if I could go through this graph and find a point where it's right on the corner of all of those dark squares. And I actually have a point right there, so I'm going to make that point and circle it. And it's also kind of best practice when we're doing this. If I have one point right there, I'm not going to do a point kind of right next to it. I want to go really across the graph in one direction or the other. So actually, I might want to make my first point down here somewhere, but I really like this point because it's right there where these things cross. So that means I need to go further up the graph somewhere. So I might pick the point, this one is not bad because I actually have it on that dark line and it's one line past kind of going this direction. Let me zoom in a little bit so you can see these points that I'm choosing. There's it refocuses. I'm going to use this point because it does line up right across that dark line and it's exactly one little line past, so it'll be easy to find out what this value is. Right, the other value I chose down here was right at those where the dark squares met in the corner. Okay, so that's the kind of the most important thing to begin with, is to find those points. And I know some of you don't like marking up your graphs because they are masterpieces and works of art, but please, it is more helpful for me when I try to make sure to look at these later, or if anyone else, you're conferring notes with someone, it's good to go ahead and circle those points, put them with a different ink color, something that lets me know those are actually the points you chose to use. All right, now from here, I've tried teaching this several ways over the years in terms of what's the best way, maybe the easiest way to find out how to use the slope formula. And I've done it by actually drawing right triangles and some other methods. But the one that seems to work the best for students overall is, once again, until you're used to it, really just marking up this graph. And what you do is you take this and go across. And excuse me, maybe I'll just grab a marker of a different color so it's a little easier to see. Today feels like kind of a pink day, so let's use a pink marker here. And we'll just make that line going across. We'll do exactly the same thing at our other point. So we want to start by going exactly straight across from the points that we chose. And once again, it does not have to be on these dark lines. It makes it a little easier, but all you need to do is be able to read at what value over here, and it happens to be circumference, our y value, which y values correspond to those 2 points. All right, we need to do the same thing with the x values. So if I kind of move my paper a little bit, my x value for this one, I'm going to come straight down and see where that crosses that x-axis. And my marker's kind of wide, but at least that kind of gives me the idea of where that's going to be. And I do the same thing with this one. And already, that's kind of the way my day is going today. I picked a marker that is already dying. So for this last one, we'll switch from pink to blue. Let me try this again. There we go. So you have a blue line on that one. Okay, on my instructions, that is step number 3 and 4. For steps 5 and 6, now what we actually need are the numbers. Right? The first one, I'm just going to do the going across first, was at 64. The first one I'm looking at anyhow. We'll talk about first and second here in a minute in terms of the formula. The next one is 32. And then going down, this one is at 10. And this requires a little math because the first dark line was 20, the next dark line is 22. We're counting by twos. That means each small line is 0.4. So that one right there will be 20.4. I'm just going to kind of circle that number. Oh, sorry, it's off the page. 20.4. All right, now on the back of the graph paper, and I'm just going to use a separate sheet of paper, but on the back of the graph paper, we're actually going to write the slope formula. So we have slope equals, and you may know it as rise over run. And I find that interesting that a lot of people can tell me that, but even though they know it's rise over run, they can't really tell me what that means. And then there are some students that do remember the actual formula. It's called, I cannot write today, I apologize, y2 minus y1 divided by x2 minus x1. Now we just have to figure out what that means. Well, if we go back to our original graph, we have one point that's more on the left. It might be lower, it might be higher, but at least it's on the left of the two that we chose. The leftmost point does have an x value down below. Zoom out a little bit. Has an x value down below. It has a y value off to the side. Our leftmost point has the variables for the formula of x1 and y1. So the left numbers are 1. So in terms of our formula, I'm just going to write these all out for our formula. Right? X1 equals 10. Right? That's the x value of our first point, the one on the left. Y1 looks like it's exactly 32. Right? The one that's more on the right, once again, it might be higher, it might be lower than the original one. It depends upon how the graph goes. But it's always going to be on the right. The rightmost one is going to have the variables x2, which is 20.4, and then y2. And if we look at the y2, it looks like it's exactly 64. And I'm going to set my graph off to the side because now I have my points and I can just deal with the formula. Let me zoom in for a moment. There we go. So now we get to do some math. And I know everyone loves math. Right? Believe it or not, when they try to teach you this stuff in algebra, there is a use for it. And we'll talk about that in just a moment. So our slope is, substituting everything in, y2 is 64 minus y1, which is 32, divided by x2, which is 20.4, minus x1, which is 10. And then we do the math, right? We do across the top, which is 32. 64 minus 32 is 32. And 20.4 minus 10 is 10.4. Now in math, you may have just stopped there. But in chemistry, we like decimals. So we're going to take this fraction and actually do the math. And I know in my head it's going to be 3.1 something, but I don't know exactly what the something is. So what we will do is we'll actually use the calculator, and we will take, if you want to watch me do the math, we can do that too. Slide this over a little bit. 32 divided by 10.4 equals, oh, I was not even quite right. It is 3.076923077, which is an excellent math answer. However, once again, we are in chemistry, right? And numbers like this are not pure numbers. They are actually measurements, or in this case, calculations of measurements. So we have to go back and look at our significant figures, our sig figs. Once again, if you're not really up to speed, you're a little hesitant about what sig figs are, you can go back and watch the video labeled sig figs where I do that explanation. If I go back to our original data, what we're looking at is how many numbers are there in these measurements. And what we're looking for is what are the fewest number of actual digits in these measurements. And the fewest number looks like it's 2. We have 2 sig figs in 8.7, 5.5, 8.3, and 4.0. So when we get back to our answer, we should round up or down and only keep the first 2 numbers, which would be 3.1. The 7 would round the 0 up to a 1. So my best answer for the slope with everything I've got is 3.1. Right? And that is how we find the slope of a line. Now, why do we find the slope? Well, slope is actually a way of discovering what we call a rate. And what we will try to look at a lot of times in chemistry and physics and other classes is how do things change. We're interested in how things change. Not really how things stay the same, but we're more interested in what changes. And usually we're interested in how quickly things change. And that's what we call rate, and we find that by finding the slope. Now, the reason I actually had students measure the radius and the diameter of this, or the diameter and the circumference of the circles, is because really we should know what this rate is. As it turns out, we graphed the circumference. I'll put this over here. I'm just going to abbreviate it on the y, and the diameter on the x. So let me just write out the formula here. Circumference equals pi times the diameter. Maybe you remember that from math class. And as I said, we graph the circumference on the y and the diameter on the x. Now, if you happen to remember the formula, which is called the slope-intercept formula of a line, it looks something like this. Right, b is the y-intercept, so we'll just kind of ignore that for a minute. And if we look at the rest of it, if we graph the circumference on the y and the diameter on the x, the m, or this slope, should equal our friend pi, which is 3.14159. And our value was 3.1, which is fairly close. Right? For our y-intercept, technically that should be 0. Right? Because if we have a circle with 0 diameter, it should have 0 circumference. Now in our graph, it looks like it's a little more than 1. That means we think that when we have a circle of 0 diameter, we have a circumference of 1, maybe just a little bit more than 1. That means when we measure these, we used a piece of string around the outside of the circle. Everybody probably got in the habit of stretching that string just a little bit. Or, no, I'm sorry, actually did not have it pulled quite tight enough, because what we have thought is we thought generally, we're off by about a centimeter and just a little bit more with our circumferences. All of our circumferences as a class, because the entire class took these measurements, have over-measured by about a centimeter for the circumference. The circumference was actually about a centimeter less than we actually wrote down. But overall, this is not bad. We were looking at some sort of comparison just to do a graph. We were supposed to find pi, and we found 3.1, which is really, really close. So overall, those are the steps for finding this slope of a line. And once again, if you want to need to look at the sig fig stuff, there is a video called Significant Figures. And if you need to go back and review how to scale the smaller squares inside the big square, you can go back and look at the video that is called Scaling a Graph. Once again, thanks for watching.